Hello everyone. Welcome to our channel. In today's video, we're diving deep into one of the hottest topics in tech, generative AI. If you've ever wondered how machines create stunning art, lifelike images, or even write code, this video is for you. We'll be exploring the top 10 interview questions you need to know to stand out in the fast-growing world of AI. Whether you're preparing for an interview or just curious about the technology behind AI-generated content, stay tuned for some valuable insights and expert answers. So, let's unlock the future of AI together. Question 1. What is generative AI, and how does it differ from traditional AI? Answer. Generative AI is a branch of artificial intelligence that focuses on creating new data, such as images, text, or audio, from learned patterns. Unlike traditional AI, which is often rule-based and focuses on classifying or predicting based on existing data, generative AI models are designed to produce novel outputs. For example, in traditional AI, an algorithm might classify an image as a cat or a dog, while in generative AI, the algorithm can generate a completely new image of a cat or dog that did not exist before. Generative AI uses models like generative adversarial networks or GANs, and variational autoencoders or VAEs, whereas traditional AI often relies on deterministic algorithms like decision trees or regression models. Question 2. Can you explain how a generative adversarial network or GAN works? Answer. Generative adversarial networks or GANs are composed of two neural networks, the generator and the discriminator. The generator creates new data, while the discriminator evaluates the data and determines if it's real, from the original dataset, or fake, created by the generator. These two networks compete in a game. The generator tries to create realistic outputs, like images. The discriminator attempts to differentiate between real and generated data. Over time, the generator becomes better at creating realistic data, and the discriminator becomes better at distinguishing between real and fake. This competition drives the model to improve, resulting in highly realistic outputs. GANs are widely used in image generation, video synthesis, and even creating deepfakes. Question 3. What are variational autoencoders or VAEs, and how do they differ from GANs? Answer. Variational autoencoders or VAEs are another popular generative model but operate differently from GANs. While GANs focus on generating data through competition between two networks, variational autoencoders focus on encoding and decoding data in a latent space. A variational autoencoders consists of encoder. Compresses the input data into a latent representation. Decoder. Reconstructs the data from this latent representation. The main idea behind variational autoencoders is that they force the latent space to have a structure, which allows them to sample new data points from this space and reconstruct them into realistic outputs. The key difference is that variational autoencoders use probabilistic methods to learn the underlying structure of the data, while GANs use adversarial training. Variational autoencoders are more stable but might produce less sharp images compared to GANs. Question 4. What are the common applications of generative AI? Answer. Generative AI is used across a wide variety of industries, including 1. Image generation. Tools like DALL-E and Midjourney can generate photorealistic or artistic images based on text prompts. 2. Text generation. Models like OpenAI's GPT series are used to generate human-like text, which can be used in chatbots, content creation, or even code generation. 3. Audio and music creation. AI models can generate new music compositions or even voice synthesis for virtual assistants. 4. Drug discovery. In healthcare, generative models can be used to discover new drug compounds by generating molecular structures. 5. Deepfake creation. GANs have been widely used to create hyper-realistic fake videos, often with ethical concerns regarding misinformation. Generative AI is also becoming key in industries like fashion, designing new clothing patterns, game development, or creating characters or environments, and art. Question 5. What are the ethical challenges associated with generative AI? Answer. Generative AI poses significant ethical challenges, some of the most prominent being 1. Misinformation and deepfakes. Deepfakes can be used to spread false information by creating realistic yet fake videos of people, including public figures. 2. Copyright and intellectual property. Generative AI models often use large datasets scraped from the internet, which may include copyrighted material, leading to concerns about intellectual property theft. 3. Bias and discrimination. If the training data for generative models contains bias, the output may perpetuate or amplify these biases. 4. Job displacement. As generative AI automates tasks in creative fields, it could lead to job loss for designers, writers, and artists. It's important for organizations using generative AI to create ethical guidelines to ensure responsible development and deployment of these technologies. Question 6. What is prompt engineering in the context of generative AI models like GPT-4? Answer. Prompt engineering refers to the process of crafting effective input prompts to guide generative models like GPT-4 or DALL-E to produce the desired outputs. These models rely heavily on the prompt provided by the user. For instance, if you're using GPT to generate a story, the way you phrase your request or the prompt will directly influence the quality and nature of the output. A well-engineered prompt includes clear instructions, examples, and constraints to help the model focus on the most relevant aspects of the task. As models grow more sophisticated, mastering prompt engineering is becoming a valuable skill, especially for those working with large language models. Question 7. How does self-supervised learning contribute to generative AI? Answer. Self-supervised learning is a type of machine learning where the model learns patterns from data without the need for manually labeled training examples. In the context of generative AI, self-supervised learning helps models like GPT-3 or GPT-4 understand language, text, or images by learning from vast amounts of raw data. For example, GPT models learn to predict the next word in a sentence based on the previous ones, which is a self-supervised task. This ability to learn from context allows generative models to generalize and create new content, such as generating entire paragraphs or code snippets without human supervision. Self-supervised learning has revolutionized generative AI by allowing models to scale to enormous datasets without the need for expensive manual labeling. Question 8. What are the limitations of current generative AI models? Answer. Despite their remarkable capabilities, generative AI models have several limitations. 1. Quality control. Generated outputs, such as text or images, may lack coherence or realism, especially in complex scenarios. For example, text generated by models like GPT may occasionally include incorrect information or contradictions. 2. Data dependence. These models are only as good as the data they are trained on. If the training data contains biases or errors, the model's output will reflect those. 3. Computational costs. Training and running generative models require significant computational resources, which can be costly. 4. Interpretability. Generative models, especially neural networks, are often black boxes, making it hard to understand how and why they produce certain outputs. Addressing these limitations is an active area of research in the field of AI. Question 9. Can you explain how reinforcement learning is related to generative AI? Answer. Reinforcement learning, or RL, can be applied to generative AI to enhance its capabilities. In RL, An agent learns to make decisions by receiving rewards or penalties based on its actions. In generative AI, RL can be used to optimize the generation process. For example, a language model like GPT can be fine-tuned using RL to generate more accurate or contextually relevant text based on feedback, rewards, from human reviewers. The reward function in this scenario incentivizes the model to produce high-quality outputs. One famous application is OpenAI's reinforcement learning from human feedback, or RLHF, which fine-tunes models like ChatGPT by incorporating human preferences. Question 10. What advancements do you expect to see in generative AI in the coming years? Answer. Generative AI is rapidly evolving. In the next few years, we can expect several advancements. 1. Increased realism. Generated content will become indistinguishable from human-made content, whether it's images, videos, or text. 2. Personalization. AI models will generate highly personalized content based on individual preferences, which can revolutionize areas like education, entertainment, and marketing. 3. Smaller models with greater efficiency. With advancements in model compression techniques, generative models will become more efficient, requiring fewer resources without compromising quality. 4. Ethical and regulatory frameworks. As generative AI becomes more widespread, governments and organizations will develop ethical guidelines and regulations to address issues like deepfakes, misinformation, and intellectual property concerns. These advancements will shape the future of AI and its integration into our daily lives. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.